So calculating those binomial coefficients, and as we saw that, hey, it actually turns out to be the same as combination. So n factorial on k factorial, n minus k factorial. For a bit of fun, we're going to prove this formula via induction. Now the first case is actually going to be when k equals 0 in this one, because the first one being nc0. So the left-hand side, nc0, which of course we have defined as 1 using Pascal's relationships. We said it starts and finishes with 1 each time. And on the right-hand side, if we sub in, we'll get n factorial on n factorial, which is 1. So yes, the left-hand side does equal the right-hand side. The result is true for k equals 0. Okay, I'm now going to assume it's true for k equals r. So NCR is going to be n factorial and r factorial, n minus r factorial, where r is some integer. We're now going to prove the result true for r plus 1. So we want to prove this result. NCR plus 1, n factorial, r plus 1 factorial, n minus r minus 1 factorial. Okay, I'm going to make use again of one of Pascal's relationships, the one about adding the two above. So n plus 1 CR plus 1 I know is NCR plus 1. Now, rearranging that, on the right hand side now I have n plus 1 CR plus 1 minus NCR and NCR plus 1. Right. Okay, via my assumption, I can say that n plus 1 CR plus 1 is, because remember, at the end of the day, n was just a number. Could be anything. I didn't actually define that. Remember, it's k equals r. It's k I'm changing. So whilst I assumed it was NCR plus 1 was that, I could just as easily have said the assumption was n plus 1. So I've got n plus 1 on r plus 1 factorial, n minus r it would become if I substituted n. And the second one is, in fact, the actual assumption that I did. Now let's play around with that. Common denominator, well, r plus 1 would be the biggest, and n minus r is common in both. But r factorial, I must have multiplied by r plus 1. So when I do the subtraction, the n factorial is times r plus 1. Now on the top of the fraction, I've got n plus 1 factorial and n factorial, which would have a common factor of n factorial. But that means my n plus 1 factorial now becomes n plus 1, and it's minus all of r plus 1. So I've got n plus 1 minus r minus 1, which is n minus r, but the n minus r will cancel into the n minus r factorial, leaving me with 1 less, and I think that's what we were trying to prove, n minus r minus 1 factorial. Hence, the result is true for k equals r plus 1 if it is also true for r, and so on and so on and so on. Hence, it's all true for all positive because by induction. Okay. All right. So it's the binomial theorem that we're actually interested in, seeing this is the topic. So that right there is the binomial theorem. The 1 plus x to the power of n is nc0 plus nc1x, and so on and so on and so on. We could use some notation, and often we do, to save writing out the whole thing. So the general term would be nckx to the k, and n's going from 0 to n. And of course, we define nck as our combination that we know, so n factorial on k factorial, n minus k factorial. There will always be one more term. Remember, you start at nc0, not nc1, so you always get n plus 1 terms in your expansion. Now 1 plus x, that's kind of nice, but it's not very useful. We can extend that idea through to a plus b. The general term would become a to the power of n minus k, b to the power of k. Again, the two powers must add up to give n. Right, evaluate 11C4 without diving to our calculators. So we'll go to our definition, 11 factorial on 4 factorial, 7 factorial, and the 7 factorial will cancel into the 11 factorial, leaving me with 11 times 10 times 9 times 8 on top of 4 times 3 times 2 times 1. But then we can have some fun because 4 2s are 8. I can cancel. And 3 goes into 9. I can cancel. And so it's 11 times 10 times 3, 330. Yes, that's how we used to do it before those evil calculators. We'd actually write it out and play with the cancel. Oh, it was lots of fun. You just don't know what you're missing out on. Find the value of n. NC5 has to equal NC8. So this is where we're going to use the idea about the symmetry of Pascal's triangle. We know the two numbers on the bottom must add to give the number at the top. So that's what I'm using, that relationship. The two numbers at the bottom add to give the top. Therefore, n must be 13. So we know that. NC7 plus NC8 is 20C8. So the relationship I'm using on that one is the n minus 1ck plus n minus 1ck minus 1 is nck. So looking at that, n is 19. So if we want to find the fifth term of this expansion, well, what I tend to do is go, well, what's the general term? I call the general term k plus 1 because the first term is nc0, and I think it's silly saying, oh, it's the naughth term. So k plus 1 for the general term. It'll be 11ck, 5a 11 minus k. So the first term to the power of 11 minus k, second term. In reality, when I set my general term up, what I do is I write 11ck, 5a, I don't put any power on it. The second one I go to the power of k. So the two powers add together to give 11. We want to find the fifth term. So that's going to be when k equals 4. So if I substitute in 4, 11c4, 5a to the power of 7, negative 3 on b to the power of 4. And because I'm lazy, I've just left it as 11c4, 5 to the power of 7, 3 to the power of 4, because that's going to be like a really big number. So that is unsimplified. If you actually want to work out that number, see how big it gets, 330 times 78,102. There it is. Cool, what is that? 2,088 million. 2,000. Wow, it's big.
2 billion.
It's a big number. So a question like this then, obtain the term that's independent. So again, the first step, let's put down the general term. Now to work out independent, all those coefficients are irrelevant. It's the power of x that I'm interested in. So I want the one that's going to end up with x to the power of 0. So x squared will be to the power of 9 minus k. X to the minus 1 will be to the power of k. So we end up with 18 minus 3k as the power. That's got to equal 0. So solving that, I know it's when k is 6. So it'll be the seventh term. So subbing in, we'll get 9c6, 3x squared cubed, minus 1 on 2x to the power of 6, which unsimplified is 9c6, 3 cubed, 2 to the power of 6. All right, so 5D's playing with the actual general term expression and what have you.